Okay, let's get back to it now. The moment you've been waiting for. Okay, so far we explored how scale factors affect dimensions of an object, but how does enlarging or reducing an object affect the area, surface area, or volume, right? So we'll explore that. So let's assume that obviously this is our original, this is our new shape, and everything has been affected by a scale factor of 2. What does that mean? Well, the height here will be 2 times 3, which is 6 centimeters. This dimension here, which we'll call the length, is 2 times 5, which is now 10 centimeters. And this is 2 times 2, which is now 4 centimeters. And I guess the important part to remember is that we used a scale factor of 2, and so every single dimension has been affected by that scale factor. Okay, so in a sense, to go from here to there, K is equal to 2 or 200%. So there's a 100% increase from one to the other. And I use Tinkercad for this. I don't know if you've ever used Tinkercad in one of the shops, right? What's the one called where you 3D print and stuff like that? Right now I'm not drawing a blank, but actually my son introduced this to me. They use Tinkercad in junior high as well, right? To do 3D printing, so that's pretty cool. Determine the dimensions, length, width, and height of the new prism. We did that, check, right? So and then now we're going to look at determine the surface area of each prism. And remember, that's our formula for surface area. So here we go. Surface area of the original. I'm going to cram it in a little bit because I want to focus on our results. So maybe I'll ask you this before I start. How is the surface area of this one going to be different than this one? We doubled all the sides, right, to get this new big shape. What do you think is going to happen to the surface area? Is it also going to be doubled? Is it going to be twice as much, or is it going to be more than just double? Well, let's look at that and see what happens. So we went 2 times length times width, so 5 times 2, plus 2 times, I'm going to go 5 times 3, plus 2 times 2 times 3, right? So length and height, width and height. So that would be our surface area there. And so we get, this is 10 times 2 is 20, plus 15 times 2 is 30, plus 6 times 2 is 12. And that gives us 62, right? If you add this up, that's 62 squared centimeters. Now let's compare that to our surface area of the new shape. Surface area of new, we go 2 times 10 times 4, plus 2 times 10 times 6, plus 2 times 4 times 6. So we're just actually exploring this, like how much bigger is it going to be? So we have 40 times 2 is 80, plus 10 times 6 is 60, times 2 is 120, plus 4 times 6 is 24, times 2 is 48. And you can tell already that it's going to be much bigger than just twice, right? It's going to be more than twice as big because this is already 200 plus 48. That's 248 centimeters squared. So remember how we always went to find a scale factor? You know how we always went new over original? when we could, right? So let's do that. So if you go surface area of the new and you divide it by surface area of the original, not length, not width, not height, but surface area in this case, a two-dimensional measure. Okay, we take the 248 squared centimeters and we divide it by 62 squared centimeters. That cancels out exactly the way we want it. And what do we get when we divide 248 by 62? 4, right? I heard somebody say 4. Yeah. There it is, 4. So we're now determining that the surface area has changed 4-fold, right? Not just 2-fold. It's like all the dimensions, the linear dimensions were affected by 2, but here we have a 4-fold change. How else can we rewrite 2 when we're using powers or exponents? We can say 2 to the power of 2, correct? And I want you to highlight that 2 there, because we remember, oh yeah, the 2, that was our actual scale factor, right? That was used. So really, if we had just squared it, right, then we could have said, hey, the surface area will be affected by a factor of 2 squared. Okay, so I'm gonna just say that this is k, right? K squared. Let's go k squared. So I'm gonna make a note here. Even though the dimensions were affected by 2, the surface area has been affected. Let me zoom into that. Some of you are squinting there. Is that better? Even though the dimensions were affected by 2, the surface area has been affected by 2 squared, which is 4. Okay? That's what I'm trying to get at here. And we know that this is an enlargement because k is bigger than 1. We could have had the same scenario with a reduction. Like if I had reduced that original, we would have come up with the same conclusion. However, this wouldn't have been a whole number, it would have been a fraction. Okay, you will see that later on. And these are the 2 important formulas that I want you to write down, and they should find their way to your study sheet. I'm going to say that k squared is surface area of diagram over surface area of actual. That's one of them. And an alternative version of this, it's just an alternative, it's going to be nu over surface area of original. And sometimes, guys, or actually you're going to find that quite often, Mr. Dirks has never said anything. It just says there's this can and we're making a replica of it, a Coke can, and they're making a replica of it. Think original and then new. That's what I would do. I tend to go here right away just to make it easier. Okay? So let's talk volume. Determine the volume of each prism. Volume of original, that's a lot easier. Length times width times height, right? So 5 times 2 times 3. Volume of original, 5 times 2 is 10, times 3 is 30. 30 centimeters what? Cubed. Let's go to the new one. Volume of new. I'm just looking at my numbers there. 10 times 4 times 6. I'm going to go 6 times 4 is 24, times 10 is 240 centimeters cubed. So let's do the same thing. Volume of new divided by volume of original. We go 240 centimeters cubed over 30 centimeters cubed. Cancel out. What's 240 divided by 30? I actually did that. Remember the mistake I made? I think we used the same numbers. That would be 8. How can we make the scale factor show up here? How can we rewrite that so the scale factor shows up? How else do you get 8? 2 to the power of 2 cubed. 2 to the power of 3. 2 to the power of 3. There's our scale factor again. Okay. K cubed. Dimensions. Affected by 2, right, comma, volumes affected by 2 cubed, which is 8. That's how it goes. So here, these are the formulas. K cubed, it's going to be volume of diagram over volume of actual. Sometimes students will miss the fact that we're talking volumes, like milliliters, for example. Milliliters in a can, that's volume. Liters, gallons, right? Centimeters cubed for sure, meters cubed, yards cubed. When students see the 3, they're like, yeah, this is volume. But milliliters and liters is also considered volume. Another version of it is volume of new over volume of original. Use them as you see fit. Okay. And this is what I'm trying to say here, guys. I'm going to grab my calculator to just make it a little faster. If I have 2 shapes, let's say they're 2 spheres, right? And I change the radius from one to the other by a factor of, let's say, 5. I make the new sphere 5 times bigger. Then the surface area from one to the other will be affected by a factor of 5 squared. You squared x2. Right? The surface area will be 25 times bigger. And the volume will be 5 to the power of 3 times bigger. The volume will actually be 125 times bigger when you do make that change. Okay? And I think I'm going to use a different color and just remind you that these centimeter squares are actually supposed to help you remember, okay, we're talking the scale factor in this case has to be squared. Okay? I'm going to use a different color here. We had centimeters cubed, right? Therefore, my scale factor will be affected by a power of 3. We don't have space, but I'll do one more here. Just, you don't have to copy this, just pay attention. I hope it sticks. Here, right? So, let's say I have my big sphere. Okay? And I'm making a smaller one. Okay, let's say the radius of this one, was 10 inches. So this is the original, and this is the new one. And the radius of this new one, let's say I make it 5 times smaller. So this would be 2 inches. Right? Radius is 2 inches. Hey, let's find out the scale factor. There's just a scale factor. I go new, right, over original. What would that be reduced? 1 over 5, right? So we know that a reduction happened, and this is my scale factor. The surface area from this to this, right? How will that have been affected? So these are just the radius to get from this radius to this radius, it's just 1/5, okay? To get from this surface area to the new surface area, what's going to be the scale factor that affects it? 1/5 to the power of 2. To go from this volume to this volume, how will that have been affected? Not just 1/5, but 1/5 to the power of 3. That's how everything is related, okay? Everything is affected by, so you start with your scale factor, and this 1/5 affected our one-dimensional, right, radius. But if you had surface areas, you'd have to square it. If you had volume, both of the volumes, right, you'd have to cube it to see the relationship. Okay. So if you're scratching your head a little bit, that's okay. Well, we'll do more here. So come with me to page 34 and put this to the test. Now that we know this, how can we use it? Guys, this is key. This is going to be my starting point. As soon as I have surface area, boom, I'm going to go to one of these. 99% of the time, I'm going to use new original. As soon as I see volumes, boom, I'm going to grab one of these two to get me started. Most likely going to be this one. Okay. So let's go. Consider two similar cylinders. Similar actually is it's guaranteeing you that everything has been affected by the same amount. If things aren't similar, technically we can't do what we're doing here. Everything we've done would consider two similar shapes, okay? By what factor has the height and radius been affected? It means scale factor, right? Okay, so let's see here. Both of these are one-dimensional. No areas, no surface areas. So we stay with what we've been doing so far. We have, if this is the original, then this is the new shape. We can visually see that an increase happened, an enlargement. So let's go with height first. We can just use K is height of new divided by height of original. That's how we would find it, scale factor. So let's go ahead and do that. We have both, right? 5 inches, 15 inches. Mr. Dirksen, make sure you put them in the right place, right? Would you agree? Don't throw me off again. I can't handle it. So I use both of these heights and just transfer them over. And so what is that? 15 divided by 5? 3, right? Exactly 3, or 300% if you'd like. If these are similar, you should come up with the exact same result if we're now comparing radii, right? K is R of new, R of original. K. So here we have new is 9 inches, 3 inches. So we don't even need to worry about converting units. K is equal to 9 divided by 3, which is 3, 300%. Why did you do that? I just want you to see that this is true regardless of how you had approached it. Are there any squares or any cubes here? Nope, because it's just radius, height, length, anything like that that's one-dimensional, you keep it like that. There should be no square or cube. Now, watch this. By what factor has the surface area been affected? By what factor has the surface area been affected? Can you tell me, can you forecast what it will be? It will be 3 squared, right? It will be 3 squared. But if you don't believe me, here we go. It's surface area, so we're talking two-dimensional. Okay, so I'm going to go k squared is equal to surface area of the new divided by surface area of the original. Okay. Everything is given here, you just have to plug in. So we're going to go k squared is equal to, make sure you write this down, the surface area of the new shape is given to you, watch right here. Should I highlight that? And the surface area of the original is right there. Okay, just pops a bit more. So I'm going to grab that 1357 1680 inches squared, or squared inches, and the other one is 150.7964 squared inches. Cancel these out. And this is where most of the mistakes happen. This is done quite well. But if you want to just find k, right, what should you do to both sides? Like there's k squared, you just want k. Remember your Pythagorean theorem? You need to square root both sides. So I'm going to go and actually use a different color because a lot of students miss that. And so k, this cancels out the exponent there. And here you need to use your calculator. Grab your calculator. I'll show you how to type that in correctly. Okay, so 1357.1680 divided by 150.7964. I like to do this separately. You hit enter. It's almost exactly 9, but you can use all decimals, right? How do you do square root with this calculator? I strongly disagree with the way they should have a square root button, but this calculator doesn't. So you got to go second and then press x2. So second, you see that arrow up as soon as you press second, and then go x2, it brings in the root. You see that? And I do a copy paste every time. So I go up, hit enter to paste it into the root, and then hit enter one more time. And obviously our answer is 3, right? But it won't always be like that, okay? So our answer is 3. That's the scale factor, right? Surface areas have been affected by k squared. So we have to say 3 squared, which is 9. So you found your scale factor, but the surface areas really have been affected by a factor of 9. Okay, so that's important to note there. So we just found the scale factor that the dimensions have been affected by, but the actual surface areas were affected by a factor of 9. You got to remember that. By what factor has the volume been affected? So since it's volume, we're going to use k cubed. So you go volume of new over volume of original. And I'm running out of highlighters. I have green and I'm going to use this one here maybe, right? So the new is right there. And the original, I'm going to use green right there. So let me just do it on the side here. That's 3817.0651 cubic inches divided by 141.3717 cubic inches. And now I realize the way I want to show my work, I shouldn't have done that. But I'm going to do it one more time, sorry guys, because I want to show the root. I usually just show the last step. We don't need the cubic inches, those will cancel out. Those will cancel out here. 141.3717. And now you need to cube root. Cube root both sides. So k, we cancel that out like that. K is still going to be 3, all right, guys? It can't change. But we're just showing that you can use the volume to get there, okay? So you need to pay attention how I type this in. 3817.0651 divided by 141.3717. I hit enter. And this is a bit trickier. So you got to use math, the math button. Press math, and then you go to the fourth option, right? That's your cube root. You hit enter, then I go copy the previous answer, paste it, and there you have it again, k is 3. Volumes have been affected by k cubed. K cubed, right? So k cubed is 3 cubed, which is 27, right? And there you have it. The 27 actually showed up when you divided the volumes, right? So there you have it. We already did this part. I don't know why I'm asking you that again. The actual scale factor is 300%. The new shape is how much larger? We go 300% minus 100. So it's actually 200% larger. And this I think I need you to cloud this in. This is really the ultimate test if you understand what's happening. Okay, the scale factor never changes, but when you're talking surface area, you have to make sure you square your scale factor to say, hey, it's been changed by a factor of 9. And when you're talking volumes, it's like, oh, that's my scale factor, but really it has been changed by 3 cubed, which in this case is 27. All right, let's keep going. I want to give you at least one more example here. No, that one I'm gonna assign 35 for homework. So homework so far, page 35. I'm just going to say 35, and I will add to it as I move. So just make that your homework for now. Let's keep going. I'm going to go to 37. Okay, here we go. An ice cream shop is making a smaller cone for smaller children using the diagram to answer the following, or use the diagram to answer the following. Determine the scale factor used to create the smaller cone. Okay, so in this case, you have both diameters. Hold on, original, replica. Is that something I taught you to use, replica? Not really, right? So when it's original, we're going to call this one, we're going to rename it new, okay? Just to make sure we don't mix things up. We have both diameters, right? We are given both diameters. This is one-dimensional, okay? So you gotta make sure you take a note of that. So all I have to use is K is diagram of new, diagonal of new, diagonal of original. So we're gonna go ahead and do that. New is 1.77 inches, and the other one is 2.5 inches. Nice, we can cancel, no conversion necessary. I'm just gonna multiply both. You can either, because I didn't specify, let's just get it as a decimal. So we're gonna go 1.77 divided by 2.5. And that's 0.708. So I'm just gonna go, this is equal to 0.708 or 70.8%. Okay, so you can just state it as a decimal if you want. If I don't ask you to stick with a fraction, just go decimal right away. I showed you the trick how to simplify a fraction, right? Just in case, because you never know. If you have that, you go math, enter, enter, and it turns that into a simplified fraction, which is 177 over 250. If you really like to do that, you go for it, okay? Determine the amount of waffle dough required to make the original cone. This is hint, hint, surface area, right? When you're wrapping something, painting something, anything like that, you're covering, that's surface area. 1D, 2D, or 3D? If it's surface area. 2D. Right, thank you. 2D, yes. Which means you should be thinking k squared, or k cubed? K squared. There you go. You got it. Which means I'm going to use my, go to my study sheet, and I'm going to have a formula for k squared, k cubed. I'm going to use k squared. So that's why I set this up. K squared is surface area of new, surface area of original. Just use that. Like that is your starting point. If you get this right, everything else will follow. Do I know k in this case already? Have I figured it out already? The scale factor, just k. And you should say, yes, I already know what the scale factor is in this case. So I'm going to plug this into that. So watch this, 0.708. But you're not going to forget to square it, because it's asking you to square it. Okay? So this number, because I knew what it was at this point, I'm plugging it into my formula. And on the other side, do I know the surface area of the original? Do I know this one? It's unknown to me. I'm going to call that x. So this is x, and the surface area of the new, I do have that information. So it's It's kind of going back to proportional reasoning, but I'm adding squaring in this case. Okay. This is what I want you to do. Grab your calculator. If it's a decimal that you're using, I prefer fractions, to be honest, if at all possible, but because this is a finite decimal, I just used it. 0.708 to the right, x2. Write down the whole thing, or you can go dot dot if you'd like. But this isn't too bad, so I'm just going to leave it like that. And you have 10.15 squared inches over x. Does this look like a proportion to you? Just wait, magic. I do magic on the side. Does that look like a proportion to you? That's my magic trick. It's not very impressive, but anything over 1 is just the same, right? It doesn't get changed at all. It doesn't affect it. So now, what are we going to do? Cross, multiply, and divide. Cross, multiply, then divide. So I want you to show me that step. X would be 10.15 squared inches times 1. Duh, that's just going to be itself, Mr. Dirksen. Why do you bother? That's okay. And there, should your answer be smaller or bigger than the small cone? Should be bigger, right, for the original, because we know it's the larger one. So let's see how this works out. 10.15 times 1, not going to bother. I'm just going to go divide it. Copy, paste, because I have that number on my calculator. And there it is. 20.25 squared inches. Because I have squared inches, my answer is going to be in squared inches. Mr. Dirksen, will we ever ask square feet all of a sudden? Like just throw it in there? Maybe. But you know how to convert this to square feet, right? You should know by now. Anyways, that's the answer. I only have 3 minutes. This is what I'm going to do. I'm going to post a video on this, and so you fill this in, because I don't want to run right to the end. So, and then, hold on. I want you to do 35, 36. There's not much on 36, to be honest. 35, 36. 38, 39. Am I going too far? 38, 39. This is what I'm going to say. If you do 35 and 38, if you don't have time, because life is busy, if you do those two, you're at least going to be in pretty good shape. And then if you have more time, you do the rest. Thank you guys. Have a good weekend. Watch for that video on cubic, right? I mean, it's the same idea. It's just you need to cube it. I showed you how to cube root, so you should know how to do that part.